Welcome to the Department of Mathematics. We have seen in last lecture the applications of the Morse theorem. The applications in, in these applications we are we learned the first application, the nth root of unity and example. In this lecture, we will learn the examples on the applications of nth root of unity. Now, example 2. Find all the values of bracket minus r raised to 1 by 6. Now, solution. Bipolar form of a complex number. Let denote the z, the complex number for this, equal to the minus I raised to 1 by 6. Now, the complex number minus I, we denote that minus I is equal to the r into bracket cos theta plus I sin theta, which is the number 1. Now, we find the values of polar coordinate r and theta. Okay. Now, we denote minus I is a complex number. Here, let x plus iy is equal to minus I be complex number. Now, comparing the real and imaginary part to the both sides, and therefore x equals 0, and here the real part is RHS is 0, and the real part of LHS is x, and therefore x equals 0. An imaginary part in LHS is y, and imaginary part in RHS is minus 1, and therefore y equal to minus 1. Therefore x equals 0 and y equal to minus 1. Now, we find the polar coordinate r equal to square root x square plus y square. We put the values of x and y in this. Okay, we get, so 0 square is 0 plus minus 1 square is 1, and therefore r equal to the root 0 plus 1, therefore root 1 is 1, and therefore value of r is equal to 1. Now, theta equal to the tan inverse y by x. Theta equal to the tan inverse of the value of y is minus 1, and the value of 0 is 0, and therefore the tan inverse of minus infinity. Now, we find the angle theta. Now, tan inverse goes, so tan of theta equal to minus infinity. Now, we know that this tan of theta is sin theta upon cos theta. Now, we know that sin of pi by 2 is 1 and cos of pi by 2 is 0. And therefore, also we know that by trigonometric formula, sin of minus theta is minus theta. And therefore, the angle of theta is minus pi by 2. So, the value of tan of theta is minus infinity. So, angle of theta is minus pi by 2. Okay. Now, we put the values of theta equal to minus pi by 2 and r equal to 1 in the equation 1. And therefore, from 1 minus I is equal to the 1 into bracket cos pi by 2 minus I into sine of pi by 2, because sine of minus pi by 2 is minus I sine pi by 2, and cos of minus pi by 2 is cos pi by 2. Now we simplify by using the trigonometric formula. Cos of minus theta is cos theta, and sine of minus theta is minus sine theta. Okay. Now we generalize this formula, because the value of cos of pi by 2 minus I sine pi by 2 is, is equal to minus I. But other values also, up to the n values, the angle, the values is equal to the minus I. So it is said to be generalized formula. Now adding this angle plus 2k pi. Okay. And therefore, the generalized in the form of a value k, and that is k equal to 0, 1, 2, 3 up to the n. And therefore, minus I is equal to cos of pi by 2 plus 2k pi. Okay. Minus I sine of pi by 2 plus 2k pi. Okay. And therefore, for k equal to the up to the n value generalizer, k equal to 0, 1, 2, 3, 4, and up to the n minus 1. So each the value of k, we simplify this, the value is equal to minus I. So this formula is said to be generalized formula. Okay. Now here we have given in this example n equal to 6. Now we put n equal to 6 here. So 6 minus 1 is 5. So here in this example, the value of k are 0, 1, 2, 3, 4, and 5 up to the. Okay. Now taking the 6th power to the both sides, and therefore we get the value in the form of k. Now we denote this is the zk, and therefore zk is equal to the here raised to power is 1 by 6. So bracket minus I raised to 1 by 6 is equal to the this square raised to 1 by 6. Now bracket cos of pi by 2 plus 2k pi minus I sine of pi by 2 plus 2k pi raised to 1 by 6. Okay. Now we simplify first is equal to the now take the LCM. Okay, and now cross multiplication, we get cos of pi plus 2 into 4k pi upon 12 minus I sine of pi plus 4k pi cross multiplication 4k pi upon 12. Okay. Now uh, again we use the demod theorem and therefore we get the result. So zk equal to the cos of pi plus 4k pi upon 12 minus I sine pi plus 4k pi upon 12. Now equation 2. And the value for this example a are 0, 1, 2, 3, 4, 5. Okay. Now we find the six roots of the given complex number for putting the values of k. Now first we put the value of k equal to 0 in equation 2. Now from 2 z0 is equal to the cos of pi plus 4 pi into 0 is 0, and therefore it is plus minus I sine of pi plus 4 pi into 0 upon 12. And therefore, we simplify this is z0 equal to the cos of pi upon 12. This is 0 plus pi, and therefore pi upon 12 minus I sine pi upon 12. So this is the first root of the given complex number. Now, we put k equal to 1 in equation 2. Now, from 2, z1 equal to the cos of pi plus 4 pi into 1 upon 12 minus I sine pi plus 4 pi into 1 upon 12. And therefore, we simplify this 4 pi plus 5, 5 pi, and therefore cos of 5 pi upon 12 minus sine of 5 pi upon 12. Now, this is the second root of the given complex number. Now, we put the value k equal to in equation 2. Now, from 2, z2 equal to the cos of pi plus 4 pi into 2 upon 12 minus I sine pi plus 4 pi into 2. Now, we simplify this 4 pi into 2 is 8 pi, 8 pi plus 5, 9 pi, and therefore cos of 9 pi upon 12 minus I sine 9 pi upon 12. Now we simplify this, we get is cos of 3 pi by 4 minus I sine 3 pi by 4. Okay, this is the third root of the given complex number. Now, again we put k equal to 3 in equation 2. Now from 2, z3 equal to the cos of pi plus 4 pi into 3 upon 12 minus I sine pi plus 4 pi into 3 upon 12. Now we simplify this 12 plus pi 13. Now 13 pi upon 12 minus sine of 13 pi upon 12. So this is the fourth root of the given complex number. Now we put k equal to 4 in equation 2. Now from 2, z4 equal to the cos of pi plus 4 pi into 4 upon 12 minus sine of pi plus 4 pi into 4 upon 12. Now 4 pi into 4 is 16 pi plus pi is 17 pi, and therefore z4 equal to cos of 17 pi upon 12 minus sine of 17 pi upon 12. Now this is the fifth root of the given complex number. Now last we put k equal to 5 in equation 2. From 2, z5 equal to the cos of 5 plus 4 pi into 5 upon 12 minus I sine into bracket 5 plus 4 pi into 5 upon 12. And therefore 4 pi into 5 is 20, 20 plus 1, 21. And therefore z5 to the cos of 21 pi upon 12 minus I sine of 21 pi upon 12 is equal to the cos of, we simplify this and is equal to the cos of 7 pi by 4 minus I sine 7 pi by 4. Okay, this is I. And therefore, this is the sixth roots of the given complex number. And hence, these are the six distinct roots of minus I raised to 1 by 6. Hence, the solution of example 2. Now, example 3. Find the continued product of the values of roots of bracket cos of pi by 3 plus I sine of pi by 3 raised to 1 by 4. Now, first we find the roots and then its product. Okay, the value of roots of the product of this. Okay, now we find the roots of this given complex number, and then we will find the product of these roots. Okay, now first solution given, let we denote the value z equal to the bracket cos pi by 3 plus I sine pi by 3 raised to 1 by 4. Okay, now this is the uh, only one value for denote this complex number. We generalize this formula by adding 2k pi each angle. Okay, and therefore generalized formula is equal to the cos of pi by 3 plus 2 pi plus I sine of pi by 3 plus 2 pi by 1 by 4. Okay, now we simplify this. We take LCM. Now, okay, LCM is 3 and cross multiplication. Therefore, simplify format is bracket cos of pi plus 6k pi upon 3 plus I sine of pi plus 6k pi upon 3 into bracket is 1 by 4. And by using the De Morgan's theorem, so we get equal to the cos of pi plus 6k pi upon 12. So plus I sine of pi plus 6k pi upon 12. So 4 is multiplied here 3. And therefore, this is the by using the De Morgan's theorem, we get this. So here this simplification generalized formula in the form of k. So we denote it is a zk, and therefore zk equal to the cos of pi plus 6k pi upon 12 plus I sine of pi plus 6k pi upon 12 equation 1. Here the n value is 4, and therefore for the values of k is equal to the 0, 1, 2, 3 up to the n minus 1, and therefore here n equal to 4. Therefore the value is 4 minus 1 is 3, and therefore the values of k equal to 0, 1, 2, 3. Okay, 4 values. Now we find the 4 roots of the given complex number for putting the values of k. Now first value we put k equal to 0 in equation 1. Therefore from 1 is equal to the z naught is equal to the cos of pi plus 6 pi into 0 upon 12 plus I sine of pi plus 6 pi into 0 upon 12. Okay, now we simplify this. 6 pi into 0 is 0, and therefore pi plus 0 is pi. Okay. And therefore the simplified value is z naught is equal to the cos of pi upon 12 plus I sine pi upon 12. This is the first root of the given complex number. Okay, now we put k equal to 1. Therefore, from equation 1, z1 equal to the cos of pi plus 6 pi into 1 upon 12 plus I sine of pi plus 6 pi into 1 upon 12. Now we simplify this. 6 pi plus pi, 7 pi. Therefore, z1 equal to the 7 pi upon 12 plus I sine 7 pi upon 12. This is the second root of the given complex number. Now, we put k equal to in equation 1. Therefore, from 1, z2 equal to the cos of pi plus 6 pi into 2 upon 12 plus I sine of pi plus 6 pi into 2 upon 12. Now, we simplify this. It is 12 into pi is 13, and therefore z2 equal to the cos of 13 pi upon 12 plus I sine of 13 pi upon 12. This is the third root of given complex number. Now, we put k equal to 3 in equation 1. Therefore, from 1, z3 equal to the cos of pi plus 6 pi into 3 upon 12 plus I sine of pi plus 6 pi into 3 upon 12. So it is 18 pi plus pi 19, and therefore z3 equal to the cos of 19 pi upon 12 plus I sine of 19 pi upon 12. So this is the fourth roots of the given complex number, and hence these are the 4 distinct roots of given complex number. Okay, now we will find the product of these roots. Okay, now product of all 4 roots is given by. Now first root z0 into z1 into z2 into z3. Okay, we put all the values in the bracket. First z0 root bracket cos of pi by 12 plus I sine pi by 12 into second z1 root cos of 7 pi by 12 plus I sine of 7 pi by 12 into third root cos of 13 pi upon 12 plus I sine 13 pi upon 12, and fourth root bracket cos of 19 pi upon 12 plus I sine 19 pi upon 12. Okay. Now these are the 4 factors product. Okay. Now first we take these two products. Now we multiply each factor to the bracket of first bracket to the second bracket, and by using the trigonometric formula, cos of a plus b is equal to the cos a cos b minus sin a sin b, and other trigonometric formula, sin of a plus b is sin a cos b plus cos a sin b, and simplify this. Okay, so first we multiply these two uh, factors, then we get the result cos of pi by 12 plus 7 pi by 12 plus I sine of pi by 12 plus uh, I sine of 7 pi by 12. Okay, this. Next, we multiply the other factor third factor, as we get the three factor multiplication. The multiplication is cos of, and using the trigonometric formula. Okay. So cos of pi by 12 plus 7 pi by 12 plus 13 pi by 12, and plus sine of, I sine of, so pi by 12 plus 7 pi by 12 plus 13 pi by 12. Okay. Again, we multiply the fourth factor in the, so fourth factor multiplication is, okay, so cos of is equal to cos of pi by 12 plus 7 pi by 12 plus 13 pi by 12 plus 19 pi by 12 plus I sine of pi by 12 plus 7 pi by 12 plus 13 pi by 12 plus 19 pi by 12. So here we uh, take the first two product, and by using the trigonometric formula, cos of a plus b is equal to the cos a cos b minus sin a sin b, and sin of a plus b is equal to the sin a cos b plus cos a sin b. Again, this multiplication, we multiply third factor and using this trigonometric formula. Again, these three factors multiplication, we multiply with fourth factor and we use the these three trigonometric formula. So simplified result is this. Okay. Now here we simplify again this. So LCM is 12, and therefore cos of uh, 5 plus 7 pi plus 13 pi plus 19 pi. So it is a 45 upon 12 plus I sine of 45 upon 12. Okay. Now again we simplify this angle in the form is equal to the cos of 48 pi upon 12 minus 8 pi upon 12. So LCM is 12, so 48 pi minus 8 pi is 40. So this is the simplification product. Plus I sine of is also similar. 48 pi upon 12 minus 8 pi upon 12. Now again we simplify this. 12 into 4. 12 into 4 is 48. And if 4 into 2 is 8, 2 here, suppose 3 here. And so simplified is cos of 4 pi minus 2 pi by 3 plus I sine of 4 pi minus 2 pi by 3. Again, we use the cos of a minus b formula. So cos 4 pi into cos 2 pi by 3 plus sine 4 pi into sine 4 pi, sine 4 pi by 3. Now we know that the cosine values for the positive integer is positive even integer is 1, and odd integer is minus 1. And so therefore the cos of 4 pi is positive 1 and into cos of 2 pi by 3. So cos of 2 pi by 3 there. And the uh, cosine sine value for the positive, negative or positive integer is 0. And therefore sine of 4 pi is 0. So other factor is 0. And therefore only value is cos of 2 pi by 3. Okay. Here is also sine 4 pi. So first factor is sine 4 pi is 0. So first factor is 0. Sine 4 pi is 0 into cos 2 pi by 3. So this is 0. Minus cos 4 pi is 1 into sine uh, 2 pi by 3. So this is the minus I sine. Okay, this is minus I sine 2 pi by 3. Okay, here. And therefore, this is the minus here. Okay. And therefore, cos of 2 pi by 3, value is cos of 2 pi by 3. So it is a angle 120 degree. And therefore, we know that the triangle, the 30, 60, and 90 degree triangle, in triangle, so the side 1, value of the side 1 of this triangle is the from the 30 degree angle. And the diagonal is 2, and the remaining side is the value root 3. And therefore, cos of 60 degree is in first quadrant, it is 1 by 2. And here, uh, the angle is 120 degree, it is in second quadrant. And therefore, the value of cosine value is the negative, minus 1 by 2. And sine value is the positive root 3 by 2. Okay. And therefore, the value is equal to the minus 1 by 2 plus I root 3 by 2. And therefore, the product of these four roots are Z0 into Z1 into Z2 into Z3 is equal to the minus 1 by 2 minus I into root 3 by 2. So minus here. Okay. And therefore, this is the solution of the given example 4. Okay. Now, remaining parts will be continued to the next lecture.